coming years. In today's class, we are going to see circuits and networks. Basically, a problem like this has to be solved using MATLAB. So this example we have selected, and the MATLAB version of this circuit is obtained like this. And here you can see there is an indication of a display over here, which indicates that the current has to be obtained through this 20 ohms. Okay. So first, what is MATLAB? MATLAB is nothing but a matrix laboratory. It is used to solve engineering related problems by programming language like C or C++ and simulations. So these are the basic platforms we are using in MATLAB to solve engineering problems. We'll go with the basics under simulation, and later on we'll see programming related to electrical engineering or mechanical engineering or electronics engineering or any other engineering. So the first problem here is to find out the current through AB. So through current AB, we need to find out the value that is across 20 ohms. And this particular circuit we have seen in our past previous classes. So you should know actually but the actual procedure, in fact, how to solve the circuit in order to obtain the current, and then we can take the help of MATLAB in order to solve this particular problem. So find the current through AB is the interest over here, and we can solve using mesh analysis, node analysis, or network theorems. Here we are going to apply mesh analysis by taking the help of KVL. That is applying KVL in the 3 loops in clockwise direction. So this circuit composes of 3 loops. So 3 loop currents I have selected here as I1, I2, I3, all in clockwise direction. And what could be the current through AB? Current through AB is known as the branch current, which is the combination of loop currents I1 and I2. In fact, IAB can be related as I1 minus I2, because I1 direction and the direction of the given branch current is on the same align, whereas I2 direction is opposite to the aligned direction of the branch current AB. Okay, let us apply KVL to loop 1, that is this loop, first loop. So you have here minus 45 plus 20 I1 minus I2, fine, plus 10 I1 minus I3 equal to 0, which give us the equation as 30 I1 minus 20 I2 minus 10 I3 equal to 45. Let us treat this equation as 1. Similarly, for loop 2, we are going to get the equation as minus 20 I1 plus 40 I2 minus 5 I3 equal to minus 120, treating as this equation 2. And equation 3, you will get the value as minus 10 I1 minus 5 I2 plus 20 I3 equal to 20. Fine. Solving these 3 equations with the help of calculator, you can get the value of I1 as minus 0.986 amperes, I2 as minus 3.54 amperes, and I3 as minus 0.378 amperes. In fact, IAB, as I told you, I1 minus I2, already you have I1 as minus value and I2 as minus value. So I1 minus I2 will give you the value as I1 minus of minus plus I2, whose value is 2.554 amperes. So these kind of problems we have already solved in our previous classes. You can check out our previous videos how to solve the problems using mesh analysis or node analysis, and make sure whatever technique you employ, the current through particular branch has to be the same. This is the conclusion what we made from our previous classes. Anyhow, let us see how to get the value of current through this circuit using MATLAB, that is nothing but equivalent to 2.544 amperes. For this, I'll switch on to the MATLAB version. So here you can see I have a MATLAB version. So MATLAB R 2019B version I'm using in order to solve this problem. So as soon as you open the MATLAB, you can see you can get the windows, which is nothing but command window, workshop, and many other things. We are interested to go for the simulation. So if at all you click onto the simulation link, this is how it goes, and it will take some time to get into the simulation block. And here we don't have any major block diagram, so I'll go with the blank model. So you can see the blank model is going to get created, and that will take few seconds of time or few minutes of time. In fact, here, yeah, you can open this window like this. So here you can see a simulation window is open in this fashion, which is slated as untitled. You can give the title to this window. So first, let us see the circuit. Yeah, so this is the circuit created over here. You can see the same circuit where you have a voltage source of 45, 120 and 20 with the resistive parameters, and you can see current, which is our of interest to get calculated across 20 ohms, and you can see block over continues over here. So this is a diagram which is of our interest. How to create this diagram, it is very important. Okay, so this is of importance. So for this, I'll go with the version of new like this. Now this is also untitled. Okay, now this untitled, I need to get a voltage source and I need to get a resistors. So I'll use this library called library browser. So it is taking some time, and here I'll directly go. You can see here there is a block called simulink where you have common blocks over here. Commonly used blocks are there. You have wide varieties of blocks, but what is our interest? We should know our interest. So first I'll go with the sinks. Why sinks? I should know the display of the current. So I'll make this as add to the block untitled 1. So you can see from here untitled 1, there is a block over here. So this block is shifted from major block. Okay, so I can write here as display. Display I can write here. So this acts like display. Just to give difference, I'm writing this over here. Okay, and you can see I can adjust this position like this, and I can take the help of by right clicking over this display block. I can take the help of any font I can use. I can use like Bell MT, and I can use different versions of font. I can use here as 24. Okay, so 24 is done. Okay, so display block is over here. Fine. So display block you can place over here. So this is going to represent the value of current, which is of our interest. Okay, fine. Then you have what? Then you have a source voltage. For this, all of you, please concentrate on sim events and simscape. I'm clicking over this simscape. So in this simscape, I can see here electrical is provided. Under electrical, you have again sub blocks, but here I'm interested in electrical engineering, so I'll use specialized power systems. So you can see here you have the different versions of blocks. So here I'm going to click on the fundamental blocks. Fine. And in the fundamental blocks, I can see here electrical sources, electrical elements, interface elements, measuring elements. So these are of our interest. So power guy, this is also very important. So as soon as you go into simscape, under that you can go for specialized power system blocks. In that you can go with fundamental blocks, and there you can have all our electrical requirements. So first I'll take this power guy, I'll right click on this and I'll add to the untitled one. So this will go into that. Fine. Electrical sources, I'm clicking on this. Here you can see AC voltage source, AC voltage source, current source, all the different parameters, but I'm interested in DC voltage source. So I'm going to take this and I'm going to right click on this, and this will be added. Then I'm going to again go back to block of fundamentals where you have elements. Here you can see various elements are there. We are interested only in resistive parameters. So for this, I'll select series RLC branch, this, and I'll add to the block untitled 1. Okay. Now what has happened? Just go on with your blocks of untitled 1. Here you can see already we have taken a display block, and just now we have taken series RLC branch. You can see into this notation. Then you have a DC voltage source, right? Continuous power guide. Okay, fine. Now you remember we have a voltage source and we have passive elements. So how many voltage sources are there? 3 voltage sources are there. So I'll take this voltage source value as 45. I'll apply to this and apply OK. Fine. Now the value here V is having 45. Okay. So that is done. Apart from this, I have 120. So I'll take 120 with the help of Control C and Control V. I can get a repetitive block like this. I'll apply this. I'll apply this like this. And what is the position? Its position, you can see I have right click on this and I have taken the help of rotate and flip block, and under that I have taken counterclock. So this is how the block is like this. And again this is repeated in the denominator. And what is the value? That is 20. Fine. Fine. So all the blocks are connected to one another. So I'll connect this block to this block to this, and this block to this. I hope this is simple. Right. So all the blocks are connected with voltage sources. Then you have resistor. Here you can see you have series RLC branch. So click on to this and go with only resistor. Resistor you have different values like 10 ohms, 20 ohms, 5 ohms and 15 ohms. First I'll select 5 ohms. Okay, so 5 ohms is selected and 5 ohms I'm keeping aside. Then I'm taking the help of Control C and Control V, and I'm taking another value whose value is 15 ohms. 15 ohms according to the given problem selecting. So another 15 ohms is done. Then you have 10 ohms. So again with the help of Control C and Control V, I'm taking 10 volts, 10 ohms, sorry, and 10 ohms is also selected. 5 ohms repeated twice. So 5 ohms is also repeated twice. 15 is done, 10 is done, and you have 20. So 20 also we are taking over here. Right. Now you can see we have different resistor values. This is 5. Okay. So that 5 you can keep over here. And before that you remove this selection and keep 5 over here like this and give connection to this and this like this. 5 is done. Fine. Also you have 20. 20 is in between, right? Okay. So I'll take a right click on this and I'll rotate it on clockwise. So 20 is done. Okay. So 20 upper values can be connected to the terminal like this. Okay. Also you have 15. So 15 also it is on vertical way. So 15 is also done like this. And where it is, in fact it is like this over here. Fine. So 15 also connected. You can connect this again over here. So 15 is done, 20 is done. Now what is this value? This is 10. Okay, where is this 10? 10 you can connect over here, and 10 is directly connected to this also. Fine. So 10 is also done. And what? And you have 5 ohms, another one. So 5 you can take over here. You can connect 5 over here, and 5 you connect like this. Okay, this red mark you can delete it by clicking on to this, and you can delete the red one, and you can connect 5 to this blocks. So 5 is also done. Fine. And how to name them? This 45 volts is done, so you can write by double clicking over here 45 volts. Okay, so this animation is done. So 45 is kept over here. Okay, then you have 120, so 120 you take. Okay, 120 is done. Then you have 20 over here, so 20 is also done. Fine. This is 10 ohms. Okay, so on the paragraph you can write 10. The symbol of ohm is not mentioned in the MATLAB, so you have to write OHM like this, and this annotation you can use, and that 10 you can place over here. Fine. The same 10 I am taking Control C and Control V, and I'm keeping over here, and I'm writing as 5 ohm. Fine. The same 5 ohm is over here. You can take a proper Control C and Control V. With that, there won't be any problem. So 5 ohm is over here. You can increase the font size later, but you see how I'm utilizing these notations in order to describe my circuit. Fine. This is what? This is 20. So this is 20. So that is also done. And display block I'm keeping over side over here. And 20, I'm again taking the help of Control C and Control V, and I'm placing 20 over here like this, such that 120 is here, and this 20 I can later change it to 50. Fine. Okay, now you can see all the labeling part is done. Okay, and there is a display block. What is our interest? We should know what is the value of current flowing in 20, right? So what I can do is that I'll take the help of library, and again with the help of specialized power systems, I'll take the fundamental blocks, I'll take the measurements. I need to know what is the value of current, right? So current I'm going to add into the title. So this, you can see current is obtained like this. Now current has to flow from top to bottom, so that's why I'm clicking over here in order to flip the block. So the current block is flipped. Okay, this connection is removed like this, and you can place the current measurement like this and the other parameter like this, and take the output to the display block like this. Okay, now you can see a special terminal called continuous is mentioned over here. This is known as power gain. So this will help us to simulate the parameters, especially in using solver, tools and preferences. Here we have selected as continuous. In the later session, we are going to see what exactly the purpose of power gain is all about. Right now, we have taken the values over here like this. Let me take this 120 over here. Okay, and starting time and stopping time, it is according to your wish. I'm taking here as 2 seconds, or the value as 2 over here, and I'm going to run the block. So when I'm going to do this, you can see the initialization is done and compiling is done over here. Fine. And the value you can see over here, bingo, we got the value as 2.554. Okay, so this is how you have to learn basics of MATLAB with the help of circuits and networks. Okay, so this is what is done, and I have shown the different examples over here. So this is the exact font size I have increased over the elements which I have selected, whether it is a voltage sources or resistive elements. So all are mentioned like this, and you can see a display block is taken from outside to inside like this. And if I run again this block, I'm going to get the same value as 2.554 amperes. Fine. So this is how you need to solve the problems using MATLAB. So I'm closing all these blocks over here, which I have opened in our past. Okay. I hope you understood how we have taken the help of simulation block in order to solve these problems. Okay. So I'm closing all the simulation library, and just now we have seen the output as 2.554. Very good. And this is what it is need to get obtained over this particular session. So this I have mentioned in my PPT at the starting of the session, and after this MATLAB utilization, I'm going to get the value as 2.554 amperes. So the current through AB is 2.544 amperes. So this we have solved using network theory approach. That is actual way to solve the problem, and we have taken a special tool called MATLAB in order to obtain the same solution. So this is how we have to solve the MATLAB related problems. I hope you like this session. Please share among your friends, subscribe to this channel, and please press